Hi, good morning students. Today we are going to learn how to determine a resultant force. But before this, let's consider a situation. Okay, so this big ship is being pulled by these two small ships here. This small ship is trying to pull this to this direction, okay, F1. And then this small ship is trying to pull this big ship to this direction, F2. And then my question is, where will the big ship go? The answer is that it will try to move this way. Then why is it like this? Okay, so in order to answer the question that I asked you just now, we need to learn the topic today. Okay, so our topic today is 1.0 Force and Motion 2, and then we are going to talk about 1.1 Resultant Force. Okay, so our learning outcome today is 1.1.2 Determine the resultant force. Okay, but before this, let me explain to you what is the definition of resultant force first. So, a resultant force is the vector sum of all the forces acting on a point. Okay, so how do we determine the resultant force of two forces acting on a point? Okay, so today we have four situations to consider. The first one is two forces acting on an object in the same direction. The second situation is two forces acting on an object in the opposite directions. The third situation is that two forces acting on an object perpendicular to each other. And then the last situation today is two forces acting on an object in directions that are not perpendicular to each other. Okay, so now let's consider the first situation. Two forces acting on an object in the same direction. Okay, so now you have an object and then there is one 6 Newton force acting to the right direction. Now you have another force, okay, which is of 8 Newton. And then this is also acting to the right direction. So my question is, what is the resultant force? Ta-da! This is the answer. The answer is that the magnitude of the resultant force is just the sum of all the forces in the same direction. Okay, just now we have 6 Newton and 8 Newton. So the sum of 6 and 8 is 14 Newton. Since all the forces are acting to the right direction, therefore our resultant force is also acting to the right direction. Okay, so let's do a very quick recap of situation 1. Okay, so in situation 1, you know that two forces are acting on an object in the same direction. Okay, so for example, both the forces 6 Newton and 8 Newton are acting to the right. Then the resultant force is 14 Newton, okay, because 6 plus 8 equal to 14. And then the direction of the resultant force is the same as the direction of all the forces just now, okay? Okay, so now let's consider the next situation. Okay, situation 2. Two forces acting on an object in the opposite directions. Okay, so now you have an object and then one force of 8 Newton is acting to the left. Another force, which is of 6 Newton, is acting to the right. So my question to you is, what is the resultant force now? Ta-da! This is the answer. Okay, so our resultant force right now is just 2 Newton, okay? Because 8 Newton minus 6 Newton is equal to 2 Newton. So the resultant force is now 2 Newton acting to the left. Okay, so now let's do a very quick revision of situation 2, where two forces are acting on an object in the opposite directions. Okay, just now you have an 8 Newton force acting to the left and then another 6 Newton force acting to the right. So the resultant force is just 2 Newton to the left, because 8 minus 6 is equal to 2. And then you notice that actually 8 Newton is much larger than 6 Newton. Okay, so our resultant force right now should follow the direction of the bigger force. Okay, since our bigger force, okay, which is 8 Newton, is acting to the left, therefore our resultant force is also acting to the left. Okay, now let's consider situation 3. Two forces acting on an object perpendicular to each other. Okay, when we mention the word perpendicular, you notice that there is actually a right angle here. And then what does that mean? Is that this is 90 degree. Okay, that means that this, for example, this 8 Newton is a horizontal force, and then this 6 Newton is a vertical force, and then they are at a right angle to each other. Okay, that means that they are perpendicular to each other. So when you encounter situation like this, the first step you are going to do is to draw a rectangle here. Okay, so you need to draw a complete rectangle here. And then after you have already completed a rectangle here, what you do right now is to draw the diagonal. Okay, that means that you are going to use a ruler, and then you are going to draw a straight line from this object to the diagonal of the rectangle. Okay, and then this is actually the resultant force. Now, okay, so after you have already drawn the resultant force like this, what I want you to know is that actually there's another way of drawing the same graph. Okay, that means that these two pictures are actually the same. The only difference is that you just simply move this 6 Newton here to here. Okay, but basically both of the diagrams, they are completely the same. Okay, so the resultant force is still shown by this orange line here. Okay, so now you have an 8 Newton force, okay, acting in the horizontal direction, acting to the right. And then now you have another 6 Newton force which is acting upwards. Okay, so my question to you is, what is the magnitude of the resultant force now? Before this, you need to recall something. Okay, you need to recall Pythagoras theorem that you have learned. Okay, so let's say this is a right angle triangle, right? So the relationship between all the lengths here is a squared plus b squared equal to c squared. Okay, so now let's carry on our lesson. Okay, so in order to calculate the magnitude of the resultant force here, what you do is, you know that c squared equal to a squared plus b squared. So F equal to square root 6 squared plus 8 squared, and then this is equal to 10 Newton. Okay, so now you have already found out the magnitude of the resultant force, which is 10 Newton. Now I have another problem to you. How do we find the angle theta here? Okay, which is the angle between the resultant force and the horizontal force? Okay, so now in order to calculate the theta here, what you need to do is to use the trigonometry. Okay, tangent theta equal to 6 over 8. Therefore, your theta is 36.9 degree. Okay, so at the end of the day, your answer is like this. Your resultant force is 10 Newton, and then this resultant force is making an angle of 36.9 degree with respect to the horizontal line. Okay, so let's do a very quick recap on what you have learned in situation 3. In situation 3, you have two forces which are perpendicular to one another. So what you need to do is to draw a rectangle here, and then you need to draw a line from the object to the diagonal of the rectangle, and then this line is your resultant force. So now you can also consider drawing your diagram like this. Okay, now in order to calculate the magnitude of the resultant force, you need to use your Pythagoras theorem in order to get to know the formula a squared plus b squared equal to c squared. Therefore, you can know the value of the resultant force. And then you use your powerful trigonometry skills in order to get the angle theta here, so that you know both the direction and also the magnitude of your resultant force. Okay, so finally we come to our last situation today. Two forces acting on an object in directions that are not perpendicular to each other. So now you have a force F1, okay, which is to here, and then you have another force F2, which is to here, and then the angle between the two forces here is alpha. Okay, this angle can have any value. All right, so how are we going to find out the resultant force in this situation? Now, let us do some hands-on first. Is it okay? Okay, so this is our question today. What is the resultant of two forces, each of 12 Newton and 16 Newton, making an angle 60 degrees with one another? Okay, so you see this is force P, okay? And then this is force Q, and then they make an angle of 60 degrees. So may I know what is the resultant force? Okay, no worries. Let's follow the step-by-step guideline here. Okay, the first step, we need to choose a suitable skill. For example, the skill that we choose here is like 1 cm equal to 2 Newton. Okay, you may also choose another skill if that's suitable. Okay, so if we choose the skill 1 centimeter is equal to 2 Newton, then we know that 16 Newton is represented by an 8 centimeter straight line, whereas the 12 Newton here should be represented by a 6 centimeter straight line here. So now, please take out one ruler and draw a straight line of 8 centimeter. Okay, so this is a straight line which is of 8 centimeter, and then we say that this is line AB. This line AB is used to represent the force P, which is of 16 Newton here. So now we need to mark 60 degrees at point P. You take out one protector, okay, and then you place the protector here, and then you mark 60 degrees like this, and then you connect this line, and then you need to label this is 60 degrees. Now we need to draw a straight line BC of 6.0 centimeter to represent force Q. Okay, so you take out your ruler once again, and then you make a straight line of 6 centimeter here. Okay, and then you label this is line BC, and then this line is used to represent force Q. So now you need to complete the triangle ABC. So you need to draw a straight line from A to B, sorry, to C, and then this is your resultant force now. So you need to measure the length of AC. Okay, you need to measure the length of the resultant force here so that you can calculate the magnitude of the resultant force. So from this ruler, we know that the length of the resultant force is like 12.15 centimeter. And then you know that the scale is 1 centimeter is equivalent to 2 Newton. So you know that the magnitude of the resultant force is 24.30 Newton. Okay, so let's do a very quick recap on what you have learned just now. Actually, the method that we learned just now is triangle of forces. Okay, so in order to find out the resultant force, what you need to do is to draw a rectangle like this on a scale paper, and then you need a ruler and also a protector, and then at the end of the day you need to measure the length of the resultant force so that you can know the magnitude of the resultant force. To be honest, there is another method which is called parallelogram of forces, but we are not going to learn that today due to the time limit of this presentation. Okay, so today, we have already learned how to calculate the resultant force when the two forces are in the same direction, in the opposite direction, perpendicular to each other, and also acting at an angle to each other by using the method of triangle of forces. Okay, before we end the class today, let me give you one question to test your understanding. Now, what is the resultant of two forces, each of 3 Newton and 4 Newton, making an angle of 90 degrees with each other? Okay, so I give you 3 seconds to think about the answer. Now, the answer is 5 Newton, okay? Since they are at right angle to one another, you need to use your Pythagoras theorem, okay? A squared plus B squared equal to C squared, okay? So when this is 3 Newton and this is 4 Newton, you know that your answer is 5 Newton. Thank you.